company. So our project was to download lots of tweets, try to identify what the tweets were about, what was the topic behind the tweets, and then classify if it was something positive or negative. So so what we're going through is a Jupyter Notebook, which is basically code mixed with documentation and the outputs of the code execution in a single place. So this is the Jupyter Notebook. And I'm going over one session that I run through a database of tweets collected through a couple of days, and what were the steps that we did in order to reach that goal, to classify tweets if they were positive or negative. There are many approaches to that. I'm going to show just one approach, the approach we have taken, and discuss a little bit the things we have done. So I did this in Python, and most of these modules here, let me move this up here so it doesn't get away. So this Freud module here, I created from scratch. I don't think we're going to have time to deep dive into this, but later if you're interested, I can go into. But it's basically one class to encapsulate what the tweet is all about, and to perform something that we call part of speech tagging, which is basically breaking down a sentence and identify each piece of the sentence, like what is the subject, what is the predicate, where are the verbs, articles, prepositions, things like that. So there's a lot of artificial intelligence inside the algorithms for calculating part of speech tagging as well. But I recommend you guys to use something that's already done for the target language that you are interested in. And there are many libraries. So let's move on. Oh, that will be tricky. Okay. I put some music on that presentation, but it's okay. I can reduce the volume here. So the first thing is for us to load those tweets and then count how many tweets do we have in the database. And we have this number, it was about 8,000 tweets here. But then we needed to filter for that particular project the ones that were not in the Spanish language, because they were focusing just on local tweets about the company. And sometimes there's merchandise on the channel and things that are unrelated, completely unrelated. So we have to filter down. We eliminated 1,000 tweets from this sample of 80,000. And then we eliminate the duplicate tweets because there are retweets. So you have to eliminate that as well. And you end up with a much smaller base with only 1,000. So from a starting almost 10,000 database, it reduced to a single thousand of the interesting data that you're planning to tackle. Okay, so after that, we need to identify if the tweet was fully formed, or if the person half typed, sent it, and it was incomplete, or it didn't make sense, or if it's just something like, hi there, hello, good morning, things that are really not meaningful. So one way to do this is to analyze the distribution of tweets that we're going to see a little bit further down. But there are some tweets that you can identify as specific things. For instance, a tweet that has a URL in it, most of the time, is not expressing an opinion, but it's just giving information. Like, check out my new website, or look up the new products from Facebook, blah, blah, blah. So it's neither positive or negative. So for this particular work, we were not interested in tweets that was neutral. We're just interested in tweets that were revealing, oh, I'm happy or I'm sad about something. So we are discarding all of these tweets as well. And there were some tweets that were questions. So the tweets that were questions, they are also neutral by default. They are not expressing satisfaction or dissatisfaction with the company most of the time. So in order to make this simpler, we discarded all questions as well. So the remaining tweets, we did a distribution analysis, which is what you're seeing here in yellow, for us to understand how they vary in terms of size, in terms of numbers of characters. Because sometimes you can identify some tweets that are too short, like to the left, or some tweets that are too long, and maybe they are in the same category. Maybe they are just a hello thing, or a wow, things like that, and they are so short that you cannot identify a topic. And sometimes there are ones that are extremely long, and they might be some form of marketing. So it's interesting to see if the distribution is kind of uniform or not. In that particular project, this was not super relevant because the filtering we did before ended up being the most relevant thing. But that helped us to identify, for instance, the URLs and other things. So now we get into the X-ray of a single tweet. So in this step, the annotate part of speech tagging, we're doing the hard work, which is grab each of the valid tweets and break it down into its parts. So let's see one concrete example for this. So I'm getting, it takes a while. So you see, it took 34 seconds, which is a lot of time. And the reason is, for each tweet, you have to run, in our case, I was running a separate process, so it was not very performant. The best thing would be to integrate it in the single software. But since this was some offline thing, just for analysis, it didn't matter. But the actual classification, it's expensive. So sometimes it pays off. If you need to do it in real time, you might need to tweak the algorithm to be performant. And what's happening here? We're getting one tweet, which in the case was this one, which said, when I want to have some fun while I'm in traffic and I don't have signal. So, and this is the name of the company. And this is an emoticon, which is kind of a sad. So it's saying, damn, I'm driving here. I'm supposed to use my cell phone to have fun, and I cannot because there's no signal. So we humans reading this, provided that we know the language, it's not hard to understand what's the topic. So the topic is lack of signal from the company. But for the computer, how do we get to that, right? So the first thing is to identify the nouns. So usually the nouns are what you're talking about. So we did this classification. So each word is classified against a previous known class. So this is a classic problem in machine learning, where you have objects and you want to put labels on them saying this belongs to a given class. So the classes that we have when we learn our own language at school are verbs, prepositions, articles, countable nouns, uncountable nouns, and blah, blah, blah. So in this case, we are interested in the nouns because they are the what. So the nouns, the name of the class is NC for this particular library that I was using. So the candidates for topic here are cell phone, abbreviated to cell. The other one is traffic. The other one is signal. And the other one is Telcel, the company. So by using this approach, we already filter out a lot of noise regarding the targets of identifying what I'm talking about. So we go straight for the nouns. Okay, let's continue. There are other things that will be interesting later, such as adjectives and verbs. Because the adjective says, they say, beautiful, ugly, nice, ghastly. And the verbs could be, I love it, I hate it. So the sentiment hides within the the verbs and adjectives, sometimes adverbs, but the what hides into the nouns. So these were the nouns that were most relevant across all the tweet base. So we see that the top ones become the interesting topics that we should analyze. For instance, the service, the network, and the signal. So we see that they are very closely related because it's people complaining because they cannot use their phone.
You
right?
could already here make some like really rough preliminary conclusions.
Right. And this, it's very simple, and you already know where the money is. This particular job led to a second job to identify failures in telephone towers, because when a tower fails, lots of people get without signal, right? But there are other topics, like the plan, because people hire the phone and they have a plan, prepaid, things like that. The day, the word day, doesn't have much meaning, but it's a noun and it's present there, so this is noise. Internet might be related to service, to network, and call, llamada, call, it's also related. I cannot make calls. And gracia is thanks. So gracia, like day, it's just noise. And client probably has no real meaning here. So given this first analysis, you're able to filter out and identify what we are interested in. So you can create those we call stop topics during an analogy for stop words, words that have no meaning. So we have topics that do not add anything. So we're filtering out thank you and they, because we're not interested in those. And then we have the topics that we are kind of interested in: network, signal, service, internet, call, things like that. And then it comes time for us to start thinking about the sentiment analysis part. So now we identify the topics. We want to know, are they talking about some good or bad thing regarding the signal or the network or the quality of the call, blah, blah, blah. So these are just some examples that now I can use my tweets database as a database, and I can do queries and looking up for these particular nouns. And then we identify, and you can see that sometimes we see emoticons. So if you are concerned with sentiment analysis, you have to have an emoticon database in order for you to get a signal from the language itself. What we have in here, okay. So another important thing is that how do we proceed with this? Well, the easiest way is for you to get an auxiliary database that already classifies adjectives and verbs. Because we as humans know that love is something positive by default, and that I hate it, it's something negative by default. So those verbs, to love and to hate, have intrinsic classifications that the computer will never be able, it needs to be taught about it. You can do your own training, but for most languages, it's already done. So you just grab from the internet a database that's pre-classified for the target language, what's positive and what's negative in terms of verbs, and I'm being flooded here. Okay, so let's continue. So then we go over all the tweets, and then we annotate the polarity for those particular terms, because we already know which are the verbs, which are the adjectives, using the pause speech, part of speech tagging that we have done before. So we can simply apply, and then the question is, okay, how do we extrapolate from the verb not having and the word good? How do we create a formula, a mathematical formula for the whole sentence? So what we have in here, we have a phrase that says, okay, I observed that using the services from this particular company, there are certain places where I don't have 3G signal, but I have good reception and there's no data transfer. So it's seeing the bars on the cell phone. It can make calls, but it cannot use the internet part. So the data plan or something, it's not working. But the regular phone calls are working. So there are two things to observe here. First, there are two topics. So even though there is a single sentence, it's talking about two things regarding our previous classification. So it's talking about the signal and about data. And for the signal, it's positive. But for the data, it's negative. So if you try to classify the whole sentence as an absolute positive or negative, you may get wrong information because you need to go for the topic and not for the sentence. Because the sentence may cancel itself out because it's saying something positive and negative at the same time. So on the whole, it's neutral. But if you focus on the topic, it might make more sense. So what we end up doing in this was to create a distance between words in the sentence. So the topic, in this case, it's the word signal, which is in here. And what is modifying the signal? So the verb to have, to exist, is modifying the signal. And in this case, it's positive. So there is signal 3G. So then it's transferring its intrinsic positivity from the verb to the noun. And we can use this distance thing because it could have a positive verb and a negative adjective, which is more rare, but it could happen. And then you build your math function on top of this. For us, it was very simple. We simply create this distance function. So if you're close enough, the thing that has polarity, that has positive or negative connotations, is close enough to the thing that is the what, the noun, then it's transferred, and we simply sum it up. So we go ahead.
Could you have split it by the conjunction, which is pero here?
I
could make like two sentences.
Yeah, we can go, knowing the language, we can take deeper steps into isolating influences. Natural language processing is super hard. For instance, tweets make it super easier because the whole text, it's in there, and usually there's not much context. But if you extrapolate this to a conversational interface, to a bot, then it's a whole ball game because there is a context, and then I might have said something in the past that's relevant to my current sentence, especially when I use pronouns like, this is great. What is this? This is something someone said before. So it's a reference. So I have to resolve that reference prior to doing anything else. So there are other things, but since we have just 30 minutes today, I thought that we should go for the simpler, which tweets is great because they are self-contained, right? So basically, we can create this very simple formula that already works, that is simply a distance function, and we sum it up. So if either positive or negative, we sum everything that we have, and then we see if the topic, not the tweet, if that topic ends up being positive or if it ends up being negative. One thing to pay attention to is that sometimes you have logic inversors, like the not. So I could say, I don't know, that person is not beautiful. So beautiful is positive, but not inverts the polarity of beautiful, saying that that person is ugly. So ugly is negative and not beautiful, it's negative as well. So, and then the remaining part are just examples, other examples where you can have things that are kind of neutral. by themselves, or that they cancel each other, or inversions, like I mentioned. So in this example, saying this is the call center called Sheldon Cooper, and in the call center, a person called Sheldon Cooper, it's not a good employee. It's not giving good service. So this is what this is all about. And it's using the good service. It's something positive, but if there was a negative part here, it would invert this. So I translated wrong. So it's a compliment. It's saying, in that particular center, Sheldon Cooper is doing a good job. So it's positive, but it's not kind of super positive. So you can have a scale like, I like this and I love this. So I love this is stronger than I like this, which is stronger than I tolerate this, right? So you can create in your dictionary of prepositions, no, I'm sorry, of adjectives and verbs, you can create a scale. And then you have finer granularity. So our time is almost up because everybody have calls. So let's see if there was anything that's super interesting. This is an example of neutral. So there were no adjectives or verbs. It's just saying that, okay, my bill will expire on that day. So it's not positive or negative, blah, blah, blah. And the second part that we're not going too deep into, which is relevant for the case of tweets, it's to try to identify the geographical coordinates of a tweet. And then you can see if in that region, a topic, it's more popular or more relevant than in other regions. So is there a geographical aspect related to this or not? So, well, basically that is what I had to present to you guys. It's a very short introduction to natural language processing, tweets digesting, and sentiment analysis thing. Any questions?